Good evening, everyone. So we are going.
Good evening, sir.
Good evening. So we are going to get started of knife based multi-class classification, and boosting problems are also there that we have done in the previous week. So the question is, in ADA boost we reweight uh, points, giving point misclassified previous iteration more weight. So the data points which were misclassified are given more weights. Okay, suppose we introduce a limit or cap on the weight that a point can take. For example, we introduce a restriction that prevents any point's weight from exceeding a value of 10. Among which of the following will be effect of such modification? Acha. So the idea is that as one data point is getting misclassified, uh, screen. Acha. Okay. Okay. Sorry. Could not notice that. So as the data points are getting misclassified, what is happening is that we are giving more weightage to make the classification right. Okay. So what can happen in this situation is that mm, suppose just a simple classifier just to illustrate. So suppose our outlier is here. So what will happen that trying to classify this outlier will move the classifier more to the towards the right side. Okay, and in a way it will produce more errors. Okay, so what will happen is that uh, to restrict that we just give to a maximum weightage of 10. Okay, so that results in means like to ignore in a way kind of ignore the outliers and perform rest of the data. Okay, so this is the idea. So it will make it more robust to outliers. Okay, but as the outliers as it will not be able to classify the outliers, it may result in lower performance. Okay, so this is a Bayes rule question.
So, can you show the previous one?
Okay, So any doubts?
Okay, no.
Okay, so this is a simple Bayes rule problem. Okay, so can you solve this? What is the solution? Okay, so maybe let me show you something. So given that PA is equals to 0.3, okay, and so as you can see, uh, so you can understand it like this. PB is equals to true is equals to the probability 0.4 given A equals to true, okay, and B probability of B being false given A equals to true is 0.6. So as you can see, this is a redundant information. Both the probability means the same, okay. So you can just work with this one, okay. Other one is not required, okay. So P of B given A is going to be 0.4, right, and this is equals to P of B intersection A P of A. Hmm. So from this you can calculate P of B intersection A. It is going to be 0.12. Okay. Now now you have to use this data as well. Okay, and you can see that this is also redundant here, so you can just use one here, this one, okay, and calculate the result, okay, and just let me show you a bit more. So this can be written as P of B given A bar to denote not A, okay. This is going to be, okay, P of B intersection A naught divided by P of A naught, that is 1 minus P of A, okay. Now little bit of diagram. Okay, this is B, this circle, full circle is B, and another full circle is A. This is the intersection of P B intersection A, okay, and okay, and so this is our required region, okay, P B but not A, okay. So this is how much P B minus P A intersection B divided by 1 minus PA. This value is given 0.6, I think. This value was how much? Uh, uh, 0.6. Okay, so just see what you need to do here is that they have given the value of PA and subsequently P not A. Okay, but they have not given directly the value of PB or P not B. Okay, so to calculate this, our final result, that is PA given B, that is P A intersection B given divided by P of B, P of not B. Acha, okay, you can calculate this one. Okay, so for this you need the probability of PB. Okay, and also P B intersection A, which you have already got. Okay, so these two is required, PB and PB intersection A. So as you can see from here, you can calculate the value of PB. Okay, so put both the value of PB and PA intersection B to get the answer. Okay, any doubt? Any doubt? All clear? Something here. Hmm. So how you are feeling in the course? Like doable or hard? Any suggestion?
To show the last slide.
This slide, huh?
Third page, third page. Yes.
From this you have to calculate the PV. How much it will be? PA is 0.3, 0.7, 0.42 plus 0.12, 0.54. So PV is 0.54. If you put the values, you will get the answer.
So how PB intersection A becomes 0.12?
Acha, from here actually. Okay. So it is you see 0.4, this one PB given A is, you can be written as 0.4 is equals to PB intersection A divided by P A, conditional probability. Okay.
So you multiply it with zero point 0.4 into
Point 3.
0.3. PA is zero point 0.3. Okay.
Yes.
So PBA means B condition A means PB equal to true and A equal to true. Then we can say it is PB condition A. Is it?
Condition A means like given A has happened, what is the probability of B? Okay. This statement means this one. Okay.
And what about if P B equal to false and A equal to given A equal to false? Then that time what can I write in probability?
This one, this statement, huh?
False. Yes, yes.
So this is same as this one, actually, equivalent statement, because you see, like 0.6, this is, and this is 1 minus 0.6, and the case is like B equals to false, here B equals to true. Okay, and the
Mhm.
condition is same, A equals to false. Okay, so if condition is same, you can ignore the condition as well. Okay, B equals to true, B equals to false. So these are complementary. Means if you're saying like how can I write this in simpler terms, so like this will be Okay, let's see. So PB bar for not, okay, given a bar. So this is equals to P a bar intersection B bar divided by P. This is 1 minus PA, simple enough. And this one you can get it from diagram, Venn diagram. So not A, okay. So not A is outside region, okay, and not B is also outside region. This is same as this one actually. You can see. Am I correct? Let's see. Not A, not A is this region, okay. Not B is this region. अच्छा अच्छा. अच्छा यहाँ तो both है ना. अच्छा. So not A and not B both. Okay. So this is can be all the outside region. So that is 1 minus. This one is 1 minus P A union B. Okay. Okay. And this from that PA plus PB. Okay. So like that you have got it. Okay. Any doubt? Any doubt? Or is there any doubt? Who was
No,
asking?
sir, clear, clear.
Okay. So this is the theory question. In committee machines, you do not use sequentially models. Okay. So in committee machines, what you do? In committee machines, we have the B. Hmm. So in committee machines, you have the data D. Okay. And you what you use is that you use different types of classifier. Okay. SVM, and whatever not gradient descent, what do you call linear logistic regression and like that, classifiers, neural networks, okay, different weights, and you what you do is that you infer, you give them equal weights, okay, and then infer what the classification is going to be, okay. Classification can be, and as well as regression it can be, okay. In case of regression it will be the mean, okay, and in case of classification, voting, okay. Any doubt? Any doubt? Nice strength today, more than previous time. Any doubt? Clear, right? Huh? So, like, just I was asking, how are you feeling in the course? Like, is it tough, easy, funny? I mean, not funny, enjoyable, or boring? Any feedback? Tough. Acha. So, the course is actually very dense. It's not a lot of topics, as you can see. But the thing is that not all of these are very important, actually. Acha, boring. Okay, hard. So the uh, so not all of these are very useful, okay, and or maybe commonly used, okay. The popular ones are the linear regression, means, or maybe any regression that can be done, okay. Not getting curiosity means like what is the usefulness, right? So regression is important. Any type of regression problem is very popular in engineering, okay. It can be linear, it can be non-linear regression in the form of principal component analysis, or neural networks regression, okay. So these are also there, okay. So regression is important, and other than that, what is important is um, classification, okay, okay. And here SVM and neural networks, and what else is important? That logistic regression and linear classifier, LDA. Okay, these are important. Okay, and so mostly this only. Others are actually not that important. Okay, and so and PCA is important. Okay, okay. So not many topics are actually important. Okay, and so you can focus on learning those better. Okay, and in linear regression, understanding how backpropagation works is very important. Now, in neural networks, okay. So backpropagation, understanding backpropagation is very important, and implementing that as well, coding it, okay. And in case of regression and classification, implementing those algorithms are also important. SVMs and PCA, okay. So this is all actually that is important point of view, okay. First time learning this can be hard, okay. So you can prioritize on the topics, okay. So um, understood, right? Which are important. It is important to implement this as well, code these algorithms, okay. As you will find the problems in Kaggle. You can do the coding in Kaggle. I've shown you a few examples as well. Okay, any doubt? Like, any doubt? Anything you want to say? Prashant, may I know in which research area are you working? Well, this machine learning only. Okay, as I had explained before, I was in robotics. Okay. So, as you see, not all topics are very important, so you can prioritize. Coding this will make your concepts clear, how to use this, okay? Because theoretically, like learning machine learning is not the objective, okay? You should be able to implement to fulfill your purpose, okay? With example from Kaggle data point, please explain above concepts in detail. Well, I cannot explain all this now. Means I can take up back propagation again. Was back propagation clear? Like back propagation is very important, okay, and you should be clear on it. Otherwise, like building algorithms is very hard. Okay, in terms of Kaggle, okay, what I can show is like so this one I had searched before as well. So housing data set that I had given the taken up in explaining you. So here you can use this data set for regression, implement different regression techniques, linear regression, neural network regressions, okay. And you have the code means like sample code. Of course, you know should not copy. You should understand, do it yourself, okay. So as you can see, linear regression, okay. He has implemented from using random forest, okay. And you see here a person has used artificial neural network for regression. That is also common. It is non-linear regression. Okay.
Sir, can you give some example of regression analysis? Suppose in linear regression, which type of problem? You just give me the name of the problem,
Here
example problem.
the
Which
problem
type of problem?
housing prices data set. So here you have
So,
what you have to do, like I have explained in the first lecture, I think that you have to determine the price of the house given the size of the house. Okay, given the size of the house. Okay, that is area, number of bedrooms, bathroom, stories, I mean, how many floors. Main road is there or not, guest room is there or not, basement is there or not. Okay, this is the problem, very common problem. Okay,
no, actually I'm asking that suppose when which type of problem we can use the regression and which type of problem we should use the neural network and other SBM or whatever we have studied up to this.
it's like
Suppose there are now so many types it is showing up to this week. So actually, for suppose what we are feeling in our suppose I am in civil engineering background. So in civil engineering background, suppose I want to predict the ground vibration depending upon the different parameters I have.
Mm.
Okay, so which method I should use so that it will predict the correct or accurate ground vibration? For this is for the example, so that's why I'm asking like that's for suppose linear regression. You
Mm.
can use this type of problem, you can use for linear, suppose house pricing, you can use linear regression. For classification, suppose this type of problem, you can use classification problem. For neural network, this type of problem you can use. Then we can more concentrate on that, depending upon which area we are researching. So in that we will study more on that method only, not all the methods uh, rigorously.
What happens is like in civil engineering things, regression is very important. So you're correct about that. But like any type of regression
Yes.
works, any type of regression works. Okay, and there are like non-parametric methods as well, like Gaussian process for regression. Okay, those are popular as well. It's not very popular. Neural networks is popular only. Okay, so that is how you do it. Okay, civil engineering prefers to use linear regression because you can interpret it better. As you can, as I have explained, the interpretability of neural networks is poor. Okay, so for regression, civil engineering people usually use linear regression. Okay.
Suppose I'm actually I can discuss that. Suppose I am working in the mind blasting, mind ground vibration induced by the mind blasting. So in that mind blasting, so different parameters I have, data I have. Suppose the blast hole diameters, blast how many blast materials explosive we are using, what is the spacing of the two different blast holes. Suppose such kind of six, seven, or eight parameters I have, and the output parameter is my ground vibration. Due to the blasting, how much ground vibration is occurring.
Acha.
So I have the data now. Which method I should use so that I can predict the future ground vibration for the
Commonly used is linear regression. Okay, and what they sometimes use is like non-linear basis function they use. Okay, so in place of that x1 and x1 square that I've shown, there people sometimes use like sine x1, tan x2 type. That is also popular. Means like whatever works actually. Okay, that's the idea.
so whatever I paper I search in that Gaussian regression process they have used, and then they have used other machine learning methods also they have used, and they compare also. I'm not recommending all the methods now. So they used 4 5 methods, other research papers I saw. uh, Now I just want to ask which method will be the, so suppose the in the that paper I saw in the when they comparison of between these methods, they got better result in the Gaussian regression plus.
Yeah.
So is it true, or it will be
Means like
different for a different case?
it can it can be different. Means like in whatever it works. Means like in civil engineering or like blasting, as you are explaining, popular is linear regression. Sometimes they use Gaussian process. Okay, for regression. Okay, and the thing is like Gaussian process is an advanced concept. Okay, not taught in a introductory class. Okay, uh, so linear regression, I guess. Yeah. So
So as my problem is not a classification problem, so
regression problem.
yes, you are suggesting that linear regression also I can do, but in linear there is a lot of parameters are there. Input parameters are suppose 5 to 6 input parameters are there, and for that we can use linear regression. It will give it good result for that.
Is it sure?
We do re-
So like uh, so another example like for classification can be face recognition. Okay, And face recognition can be hard. Uh, so the idea is like classification. What the popular was like cancer data set, right? Cancer, breast cancer. Okay, so this is another classification problem as you see. Okay, so you can solve the problems here. Okay, and for neural networks, you can use neural network regression for regression problems. Classification neural networks is very powerful. Okay, but like as I was saying, like face classification, face non-face, right, right. Maybe this one. Sure. So different type of problems actually, but another thing is like you should be able to implement the back propagation algorithm. Okay, means like back propagation algorithm is the foundation of modern machine learning. Okay, and deep learning. So like back propagation, what is it doing? Means like uh, we are trying to train a neural network. Okay, and what does training a neural network means? I want to find the weights of the neural network. Okay, through and using those weights and basis function, I can calculate the I can have the future prediction. Okay, so how am I going to get the weights? That is the idea. That is the problem. Okay, that's not the idea. So for that, what we are doing is like we are trying to find the value of the weights, and we are doing it iteratively using gradient descent. Okay, but in gradient descent you need the gradient, that is the derivative of the cost function with respect to the weight parameter. Am I correct? Mm, okay, so this is it. So for that, what you are doing is that for the weights that are close to the final loss, that is result minus label. Okay, final loss. So the weights that are closest to the final level, we first calculate gradient with respect to them, then back propagate. Okay, what back propagate means is that using chain rule, as this quantities are related, using chain rule with successive derivative, I calculate the previous weights, previous gradients. Okay, and using that I can update the grade weights. So this is the idea of backpropagation. Okay, it was founded by, it was discovered, you can say maybe, or invented, whatever, by Jeffrey Hinton. Okay, and it started the new field of machine learning. Otherwise, that before that, it was like people mostly use SVM, sometimes PCA, but not neural networks because you could not train them. Okay, so the so back to our thing. Okay, so the final thing is that you need to implement that backpropagation algorithm to understand. Okay, it's like, have you understood the backpropagation? And overall, I don't think so. It's not an easy thing understood properly. Okay, so let's continue actually. Uh, uh, so so the complexity of the classifier means like how many steps we are required to classify the all the classes. Okay, So the idea was like that. Means like one versus one that we are doing. Okay. So like, so as you see here, so we have to classify uh, these. Okay, red, blue, green. Okay, means some object is given whether it is red, blue, or green. So what they have done is that they have um, made a thing like this. Okay, one versus rest actually. Okay, so it is red or else. Okay, blue or else, green or else. Okay, and this is one versus one. That is like for every two, means like select two colors. Okay, and then make a pair. Okay, and whether it is red or blue. Okay, like that. So number of pairs that can be formed is like NC2. Okay, so this is the classical one versus one. Okay, but what the tournament problem is, suppose I have this many classifiers. Okay, so what I'm going to do, given the data that is our object, okay, during testing, if it is not, it's like it will give some answer red or blue. Okay, suppose it is gives blue. Okay, so what I'm going to do is that then it is for sure not red. Okay, okay. So the thing is that suppose let me see. So the idea is that like suppose it gives blue, then what it means that it is not red. Okay, so the classifier in which they are red, you can just ignore them. Okay, uh, okay, am I correct in this one? And so what happens is that if blue, okay, so I'm going to ignore the red classifiers now, okay? And but here I will just do the classification again, okay? And and see that whether it gives blue or green, blue or yellow, like that, and it's like keep removing classifiers, okay, on that basis, okay. So somewhat the idea is like that, okay. So what is happening is that in this process you are reducing the number of classifiers to be used from this n square complexity term to n, okay, like that. So that is the idea. So in classical one versus one, the answer is this, but in this case, our answer is this. Clear?
Not clear, sir.
What problem?
How this n comes? Let's say classically we can get n square, but how it is become n for this problem?
What happens is that means like uh, if it is not red, then I'm just removing the red classifiers. Okay, okay. So that is how it is. Okay. So one gives blue here. Okay, that is this one, and then I will check whether this one gives blue or green. If it is blue again, okay, then I remove things with green. Okay, so in this way you get a linear number of, means you can understand that I am not increasing the dependence on one color. So okay, anyway, better to explain this one. But the problem here is that if the classifier is not means like if it is not a proper classifier, means like margin of error is not high, okay, then what can happens that you are quickly removing red here, okay, which you should not remove. Suppose if the classifier is weak here, okay, means like the red can also be the answer, okay. So you can quickly remove one thing that can be correct, one color that can be correct, okay. So that is the problem here. If the classifier weak, and weak means is that the margin of error is low, okay. Good strength here, keeping in keeps increasing. So you try to understand it yourself, okay. Maybe you can look in at this page again, okay. So now this question, okay. So this question like why is it always true type, okay. So this is little vague actually, but you have to understand in it this way that we are looking for whether the this probabilities or means like events are dependent on each other or independent, okay. As you can see, this is the idea, okay. Given g, a and b joint probability, they are separating into a, ba and bb. So what they implies to say is check whether a and b are independent of each other or not, okay. So how we're going to check, okay, is that like you can see given G, okay, so means the G has happened, okay, which means that A has happened, can has happened, means like can have happened, okay, due to G, okay. Well, WhatsApp group, I don't know overall, most probably not, okay. You can have my email, okay, to ask out if you want. Okay, so given that G has happened, okay, so it may has happened due to A and B both occurring, right? If A and B both occur, then C can occur, then D can occur, then G can occur. Okay. Okay. So the occurrence of G makes A and B tied to each other. Okay. So they are not independent in this situation. Okay. Now next is like PAI joint probability is they are saying that it is independent. Okay. So there are no conditions here. Okay. So I is dependent on H is dependent on F is dependent on E is dependent on B. Okay, and B and A are, if without any conditions, are independent. Okay, they are not dependent on each other anyway. Okay, without any connection, as you see. In previous case, there was that occurrence of G. Okay, due to which A and B are dependent, because for occurrence of G, A and B both has to happen. So there is some connection between them. Okay, but here A and B are independent. Okay, without any condition. So this is the answer. Again, E and G here. Okay, E is this one, G is this one. Okay, B and H. So like given E and G, occurrence of E and G, whether B and H are independent. Okay, so maybe it is better to write actually. I think. Okay, so given E and G, okay, B and H we are looking at. So writing will not be helpful here. Just you have to analyze the network here. Uh, so maybe little easier one here. Probability of C given B and F. B and F. Okay. So as you can see, F is dependent on occurrence of B. Okay. So you cannot remove B from here. Okay. B is the primary one here. Okay. So this is it actually. F is actually dependent on B. On other terms E. Okay. So this is not correct. Okay. And now this one. So probability of B and H both happening is like this. Okay. So what we're going to do is, so to check that, what you're going to do is like E and G both occurring. Okay. And you have to determine B and H. Okay. Okay. E and G. Sure. Acha. B and H. Acha, it is easy enough actually. Means like whatever be the condition B and H. Acha, E is occurring. Okay. Acha. And G is occurring. Okay. So like has anyone solved this problem? What is the intuition like how you solve this one? Third option. So the idea is like that only, means like given the occurrence, how is B? So if E has occurred, it definitely affects the probability of B. Okay, and like G, it also does. Okay, so is B or H independent? The question is that. Hard for me to understand now. Maybe you can do this one later. Uh, okay. Let me take a break. Okay, 10 minutes. They'll come back. Okay. This question is little strange, honestly. Or is it
Sir,
okay?
I didn't understand the previous whatever you showed. I didn't understand the question and answer.
Means like here
Actually,
in
actually I didn't understand. What did the option says?
means in every option you are checking whether two events that for which you are having the joint distribution, whether B and H are independent or not. Okay.
So I didn't understand probability B and H.
There are several, but acha, what you're saying, Arijit?
Please show the question. Suppose the first option, probability B and A and B given G equal to probability A given G and B given G.
Hmm.
What does it mean? The option, what does it mean?
Means that when G has occurred, A and B are independent of each other. The occurrence of A does not impact the occurrence of B.
So that means G is independent on A and B.
No, no, no. A is independent of B when G has occurred.
So A is independent of B when G is occurred.
Hmm.
And what is the right hand side of says?
Uh, that is what I was talking. Means like if they are written as multiplication of each other, that means that they are independent of each other. Okay. Is that correct or not? Are they independent or are they not? That is the question.
From the first option, they are asking whether A and B are independent or not
Uh-huh.
when G is occurred.
Uh-huh.
Is it?
It is not.
Actually, it is confusing.
You can also see it from this point of view, like naive Bayes classification. Okay, so G is the class actually, right? And A and B are the two features. Okay, so G is the class
Yes.
here. Okay, so for a naive Bayes assumption, what has to be is that both both has to point the arrow towards this direction. Is from yes.
So from the
So
diagram, we can say that from the diagram we can say that G is dependent on A and B. No, from the diagram,
the G is dependent on A and B. That is absolutely
A and
correct.
B both.
Yes, yes. But
Huh.
are A and B independent? That is the question. And this another way of explaining is the naive based situation in which what you are going to have is like suppose G is the class, okay, and these are the two features. So for them to be an independent, the direction of the arrows should be like this, okay, from the class to the features, okay. In this case, it is not like that. Okay, if you ignore up to this point, they are coming towards. Okay, it's another way of explaining.
What is the second option? PAI.
AI, as you can see, like they are I is dependent on what here, B, as you go there, and A is this one. Okay, A and B are means like without any condition are independent. As you can see, no arrows attaching them.
Yes. No, from the P, I'm asking what is the B option asking us?
Independence, whether
Is I is
A and I are
I is
independent or not,
A and I are
independent of each other or not.
uh,
So
I is dependent on A, but A is not dependent on I
I is how dependent on A.
because for I you
Hmm.
need C, so
But I
C is
actually
also
needs C.
dependent on.
There is no directed path from A to I, so I is not dependent on A.
But it is dependent on C, and C is
How
dependent on A.
you're seeing something wrong actually. C is
No, the direct. Look at the direction of the arrows. like from C to D, then uh, D to G, then again from G, it's ending there, right? Look at the direction of the arrows.
Oh, okay, okay, okay. In the G, it is then the direction.
So just wait for 10 minutes and then come back.
So, if anyone understood this question, can you explain? Four options. These four options.
So, hello everyone. Um, Welcome back. Um, so, the idea of section in part C has to be something like this. Like we are looking at H and B here. Okay. Then in general case, they are dependent on each other. Okay, for sure. Uh, but they say that given E and G has occurred. Okay. So occurrence of G does affect B, okay, and occurrence of E here um, affects both, as you see, okay. So in that way, they are connected, I think, okay. So well, I'm not fully sure, okay, how to interpret this one, but this is what I think, okay. The intuition is okay. D part is easy. No problem. Okay. So this question is uh, just okay. Let me write. So what you're looking at is P of class C1, okay, given x is equals to, okay, given x the features, okay. So with Bayes rule it can be written as like P of x given C1, okay, into P of C1 divided by P of means P of x. Okay, so this is Bayes rule. Okay, nothing extraordinary here. Oh my god. So as you see here, like a probability can be written as like this: a comma given a comma b can be written as pb given a multiplied a divided by pb. Okay, and okay, no problem. Next is as you see, so you have to uh, focus on this term. Okay, this is the class conditioned probability. Okay, depending on which class y uh, I am considering for the time being. Okay, so the probability of x, and by x what I mean is all the three here, single sim or means like acha means like here it is given two sim, okay. So it will like, let me write it down. Suppose single sim is x1 and that one is x2 and there is x3, okay. And means the other situation like dual sim, you can say it like x1 bar, like that, x2 bar, x3 bar, okay. So what am I looking for is that probability of occurrence of this given the class C1. So according to the Bayes rule, is naive Bayes, okay, approximation or assumption, this P of x given C1 can be written as product. Okay, so as you can see here, means like product of I, P of xi, I2, suppose this is T, okay, given C1. Okay, so this is the approximation that these features are independent of each other. Bayes rule is naive Bayes assumption that these features are independent of each other. Okay, so what happens with this is that the number of parameters required to represent this probabilities reduces actually. So our calculation becomes much more linear. Means I cannot explain you in details that part. Okay, but this is why it is done. Okay, to make the number of parameters, to reduce the number of parameters and easier calculations. Okay, and the thing is that like naive Bayes works very well in text data. Okay, this is not text data, but just for information. Okay, so this is the one. Okay, so and this px, as you know, this is the evidence, as you say, is the summation over p x c1 p c1. Okay, and not c1, this is cj, I think, cj. Okay, j2. Here the number of classes is 3, right? So this is going to be 3. Okay, so this is the p, this one. Okay, so what is the idea? Means like how we are going to do it is you are going to calculate this value for each of the classes. Okay, first of all. Okay, p x c1 multiplied c1 p of c1. So probability of class c1. Okay, what is this going to be? This is the class. Okay, and number of total elements is this. Okay, the idea is to use the maximum likelihood estimation. Okay, and from maximum likelihood estimation you will get this probability as number of these terms divided by total number of terms. Okay, very intuitive actually, you don't need to do MLE. Means there is like what is the probability of budget given these three type of classes. Okay, so it is going to be 20 by 70. Okay, so this one is 20 by 70. Okay, and in this probabilities what is going to be like here you are looking for double sim, dual sim, two sim. So 15 by, so 15 by 15 is the one, no, 5, 5. Okay, 5 by 20 multiplied no 5G compared to 15. Okay, by 20 multiplied. So here it is 0, but this is actually a interesting situation. So you must understand here, like what is this like? As there is in our data, like as there is no NFC, we are getting this 0. Okay, okay. So the idea is like in this question you can use 0 here, no problem overall. But the thing is that our data set, that is this one 20, is very small, right? Only 20 such examples I have. Okay, so what can happen that our data set is small, so it may have happened that I am getting no occurrence of NFC. If our data set was bigger, so 100 or 200 or 2000, 2 lakhs, then this can be positive as well. Okay, not 0. So the idea is to here use smoothing, means like not use 0 here, but to use something positive here. Okay, so I think that I should better explain that as well. It's important concept. Okay, but in the videos there is only like use smoothing. Okay, just a word is written. Okay, what is smoothing? How to do smoothing? Okay, let me explain that. Okay, so uh, here's our professor from IIT Delhi. So here is our naive base, as you see. So the assumption as well. Okay, that these are the features. Okay, so I'm considering as to be the product of probability of occurrence of each. Okay, and you can see the simplification as well. Just to get some idea about naive Bayes, means like what is the importance here. Uh, for a motivating example, consider building in. So as you see, the classification problem is that whether an email that I have got is spam or not spam. Okay, okay. So what they do here in this problem is that they will pass through the email and okay, and see at means like look at the words that are contained in the email. Okay, and according to those words they will means the classifier will classify it as spam or not spam. Okay, so mm, spam email example is so hard to find. Maybe this one. So as you see, okay, we're not good for the class. Okay, uh, maybe I have another example here. Okay, so this is not spam on. non-spam, but still let's see. So the our problem is to classify um, a sentence as cricket or Formula One. Okay, so what I'm doing is like I'm going to, so this is the data set given. Okay, so like this sentence is related to cricket, this is related to Formula One. Okay, so what the idea is to look at words here. Okay, so this is India. Okay, and one. Okay, maybe the, or the you can ignore. Okay, means like the classifier maker has to decide which are important word. So the is not an important word for sure. Match can be important word, means may not be important as well. We're just looking at. Okay, ball is quite a thing. Okay, Formula One, no ball is used. Like driven. Okay, can be Formula One or cricket, both. You cannot be sure here. Okay, and there is the covers here. Okay, covers. Who knows what is the meaning? Okay, boundary. Okay, like that means the classifier means like you have to select some words, right, to understand. So Bumrah, okay, is a word unknown. Fast bowler. Okay, so the idea is like the idea is let's see the idea from here. So okay, what they've done is that they have formed a dictionary. Okay, dictionary of words. Okay, and whether that word means like for our one sentence. Okay, whether which word is included and which is not. Okay, so that is how they have transformed the sentence into a vector, you can say. Okay, so this is an encoding. NB assumption you have seen. Okay, and so that so they are maximizing the likelihood. As I said, you get this expression from MLE. Okay, uh, so this is the phi I given y is equals to 0. Okay, like that. So what are these phi? Let's understand that. Okay, must be the features, I think. Still, so you see, the first feature is whether the xi is 1 or not. Okay, then the next feature is xi is equals to acha xi equals to 1 given y equals to 0. It's a different class example. Okay, and phi y is equals to p y is equals to 1. Okay, this is the class probability that we are seeing. Okay, so this is actually the real example of night base. Okay, are you understanding? Means like, or is it very hard? Hello, hello.
Yes.
Okay, so just Shravani, be on the line. Okay, just so just to understand what you have understood. So the idea you understand, right? Like given a sentence. Okay, so email will contain sentences, right? So what we are doing is like we have a dictionary or like a vocabulary, you can say, and according to that, which words are contained are in that sentence is given 1, are not contained are given 0. Okay, how is the problem is formulated, because like just knowing the algorithm is not enough. Like how are you going to solve the problem? Okay, and so the naive Bayes assumption is what you already know. Okay, nothing extraordinary there. They have used some notation here. Okay, so phi I given, so I is the feature. Okay, here, and feature denotes the which word. Okay, which word here. Okay, is it the first word, second word, third word, like that? That way I'm saying the word. Okay, okay, and y is equals to 1 denotes the class. Okay, that is the y equals to 1 most probably means here spam. Okay, and there another notation I y equals to 0 means non-spam. Okay, so this is the way they have written loss function they have defined, and this is like the likelihood. Okay, and they will do MLE here. Okay, and from MLE they will get the different expressions to calculate this. What is this? This is the probability that one element is 1 given the class is 1. Okay, okay, so using this you can see we get to the same thing that as I have shown you before. Okay, that is the just the ratio. Okay, you can read this one. I should give the link. Okay, this is a good explanation here. Okay, let's see if you can use it or not. Yes. Okay, so this probabilities are given. Okay, as we used here. If you focus on this one, hope it is not getting too tough. And this is the one, right? Naive Bayes approximation. So this one, as you see, is the probability of the class, right? And from MLE, as we have got, okay. So M is the total number of training data. Okay, they would have written. Okay, that is in our case 70. Okay, and the number of training examples for y equals to 1. Okay, so you see same. Okay, from MLE we get this one. Okay, but even without that you can I guess work. Okay, in our case, like for y equals to 1, that is like the we were looking for the budget type. Okay, so number of examples is 20 here, so here it is the 20. This is the 20. Okay, and given y I equals to 1, given that budget class, what is the training examples is our what is the probability that feature is our according to our desire. Okay, got it? Okay, the number of those features. Okay, so that is the ratio of 5 by 20, like that. It's like, are you getting it, or is it too hard? Like, any review? Prashant, any review? Okay, I'm going to explain the smoothing part now. Okay, no reviews, total silence. Lakshmi, understanding? So, and you see, this is the probability of C given X. Okay. Uh, so C given X is probability of class likelihood divided by evidence Px. That is the sum of all the classes, as I've explained here. Okay. So maybe a little bit more. Okay. So let me write it down. P of X given C2, and like that you will have, okay, all three, some value here, some value here. So, and this let's represent this value by V1, but it's 0 for now. Okay, but you can smooth it. Okay, you'll see how to do smoothing. So V1, V2, V3, and inserting in the slide. So the idea is that we need to find this one, and the formula is this. So the idea is our for budget it is going to be V1 by V1 plus V2 plus V3. This is for budget type. Okay, and for the other type it is V2 by V1 plus V2 plus V3. For another type it is V3 plus V1 plus V3. Okay, any doubt up to this? Okay, is it too hard, Arijit, understanding? Lakshmi, who answered previously, Shravani, Harapriya, LD Lingam, Ritika, Santosh. Are you understanding me? Like what is the purpose I'm doing here? Hello? No answers? Total silence. Okay, whatever you're thinking, let's move on. So this is what we're looking for. Okay, Laplace.
So what is the answer of last? What is the answer of last question?
Uh, which one? This one. This one.
Last question. Last question. The typing.
This one. Huh?
Yes, 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 yes.
So what do you understand? Wow. It's like you can say it yourself. I think at least I've explained the theory very well now. So now this is the data that is given, input data. Okay, this is the test input, and the classifier needs to predict this and calculate this probability of being cricket. What is this going to be?
I think second option
Second,
will be the answer. No?
few words that appear in front of them. This one's smooth. Yes, the thing is like that, Andy. When it's like you can see this race word, okay, does not occur, okay, okay, and boundary does occur, okay. But overall, you can see the data is too small here, okay. So this is bound to occur. Ball one was also there, I think. Yes, this is there. Just the race is not there. That is the important word, okay. So what you're getting is that this like our previous situation, P of ball given means like here you see this 0 has come, right? So this is P of an NFC given budget, okay. So in our case it is P ball given, now race given cricket, it is 0 because there are no race word in the input. What? How are you going to calculate this one? P of race, suppose R, given C cricket. Okay. So how are you going to calculate number of R? Number of R means race. Okay. 0 given what is going to be here? Number of cricket. Okay. So this is 3 here. The solution is smoothing. Okay. Because it will make the probability 0. That is the problem. This will be 1. What will be this one? Without smoothing it will be 0. So this is wrong. Okay. This is wrong. Opposite. Okay. Okay. Done. So like so much smoothing, how to do smoothing now. Okay. So as you see here, naive Bayes algorithm as you described fairly well for any problem. Simple change. Consider spam email classifier. Let's suppose that after completing the okay, because we end up discussing the conference in your emails, you start getting messages about the word names. Acha. Okay. So so uh, just a hypothetical situation. Okay, the author, the person, suppose I am, okay, I was receiving emails, okay, and based on the data on that email I have built a knife based classifier. Okay, and now what I'm getting is like I had gone to the NIPS conference. Okay, maybe I had written few emails or something. Okay, now I'm getting emails on NIPS. Okay, emails having the word NIPS. Okay, now what is happening is that my classifier is not able to perform well because there is no such word NIPS in the training data. Okay, okay, got it. Okay, understanding the problem statement. So so this NIPS, well, in the dictionary NIPS is the 30 this word. Okay, means like they have assumed. Okay, means they have made a what you call a vector, right? Vector or array, whatever you say. So this row is the row denoting NIPS. Okay, so this in our case it was 0, right? Hmm. Number of occurrences 0. Okay, okay. So you see the situation in both of these we have 0. Okay, and due to this we are having 0 by 0 means. Okay, that is a very big problem. Okay, so what is Laplace smoothing is doing, we are adding a 1 here. Okay, and this k is, let's see what is the k to the denominator. Acha, products to the mean of the multi. Acha. Multinomial random variable. Acha. Just wait a minute. Okay, we understand what is z here. अच्छा 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 got it okay अच्छा अच्छा got it okay so what they're doing is like k is the number of such features okay or is it like yeah no not the number of features k is here this okay let me make you understand this one so k is the maximum number of possible nfc that is 20 right okay and another one we are adding here okay so what you can do is like in place of this 0 you can put it as 1 okay adding 1 okay in the numerator and the total number is plus 20 okay so this becomes 1 by 40 not a 0 got it how smoothing is done nobody's answering what I am doing hello Lakshmi Sravani Rahul Ritika Sravanan Vaishnavi Harini Harapriya. Any answer? Okay, so this is not ready. Okay, who is the one? Again, silent. So this one is an important thing actually overall. Is overall very much useful in only text classification. Span or anything related to text is it is quite good. Okay, it works very well actually still now. So many modern algorithms. Okay, it still works very well. So the smoothing as you can see here another so Laplace smoothing is explained here how they have used 2 here let's see where I'm not doing any wrong Acha this is correct okay now 2 is let's see 2 is correct or not overall you got the idea right how smoothing is done Laplace smoothing okay so that it does not give 0 okay 0 is going to destroy everything okay so even without with 0 you can do this one because all the three it is not coming 0 okay so the it is does not become 0 by 0 that is the more problematic situation okay but only one is 0 v1 okay so you can calculate this okay so for v1 the probability is this okay for v2 it is v2 by this for v3 is v3 by this okay like that we'll get the probabilities and that is what they're asking for clear clear Any response? No response? What happened suddenly? Is it too hard? Others I think easy enough actually. Can anybody answer this one? Means the why is it no? Maybe a tricky question, but if you can understand it. Hello? Can anybody unmute and answer this question? Question number 3. No answer. Okay, let's finish on the this note. Okay. Okay. Any doubt? Anything you want to ask? Any doubt? Okay. Thank you everyone. Bye.